Well, good afternoon, everyone. Greetings from our nation's capital, Washington, D.C. My name is Terry McVenis, the President and CEO of RTCA. Greetings and welcome to all of you to what is now our 26th in a series of webinars, Aviation Technology Connect. And this is our third in a series of webinars on the topic of advanced air mobility. Now, we're pleased to have created this series via this platform to hear from a variety of aviation industry leaders on a broad spectrum of topics, which will educate you, further inspire you in your profession, and perhaps even evolve your thinking as to where the industry is today and where it's going in the future. As in the past, we have a great international audience with us today, so welcome to all of you joining us from the United States, Canada, many countries in Europe, the Middle East, Africa, South America, Australia, and New Zealand. And as a note, this webinar is being recorded as all of our previous webinars have been. So if you want to go back and listen to any of our previous webinars, you can find those recordings on the RTCA YouTube channel. I know many of you watching today are familiar with RTCA, but I do know we have a few first-time visitors with us. So I'll take just a couple of minutes to familiarize you with who we are. RTCA is an aviation-centered standards development organization whose mission is to inspire the creation and the implementation of integrated performance standards that meet the changing global aviation environment and further ensure the safety, security, and the overall health of the aviation ecosystem. Now, in addition to developing standards, we also provide training to government and industry personnel on the application of those standards in developing the basis for certification and testing. And on the screen, you can see a few of our upcoming training opportunities. Next month on June 5th through the 8th, we'll be offering our course on DO 178C, software considerations for airborne systems equipment and certification. And then on June 6th through the 8th, one of our newest courses on human factors in the design and certification process, actually, followed by our airworthiness security certification course in June 26th through the 29th. And you can sign up for any of those courses via our website at www.rtca.org. If you are interested or have any questions about our training, our standards development work, or are interested in becoming part of the RTCA family of members so that you can have a voice in developing standards going forward, you can contact us directly through our website or via telephone. Now, our ability to bring you these webinars would not be possible without the generous sponsorships from our industry partners. And today, I'm especially thankful to Collins Aerospace and the National Air Traffic Controllers Associations, who are our gold corporate sponsors for this year's series of webinars. As we get into today's discussions, you're going to have the opportunity to weigh in with some of your questions to the panelists. Do our best to get to all of them. So if you do have any questions, simply use the Q&A tab on the webinar platform to communicate directly with us. So let's get started. Don't have to tell most of you on here that the entire industry really is abuzz about advanced air mobility, or AAM. And the concepts of AAM have really become a reflection of aviation's continuing evolution and represents the next inflection point of change. While AAM is being spoken about as a new concept of air transportation that moves people and cargo between places perhaps not currently being served by some of the more traditional means, many of the foundational elements of this new transportation phenomena have really been in the works for many years. And in addition to some of these new technology advancements that have been made, this new part of the aviation industry has been getting a lot of political and legislative support as well from both the Biden administration, White House, Congress, and the White House Office of Science and Technology Policy. So there's a lot of energy going on about this topic. And at RTCA, we too have been putting in a lot of energy into this topic. We've held now 3 AAM workshops in our offices with industry stakeholders and regulators, the last just being yesterday. And today we're having our third in a series of 3 webinars, as I mentioned, on AAM, starting with today's focus on operational concepts and some of the challenges that the industry is facing in moving from vehicle design approval to operational approval. So I'm pleased to have join with me today another set of 3 of the industry's top experts in the AAM community. So I invite them to come on the screen now. First, we have Ms. Amber Harrison, the Regulatory Counsel for Zipline, Mr. Eric Corona, Director of ConOps and Airspace Ecosystem for WISC, and Ruby Syed, the Global Head of Air Traffic Management for the International Air Transport Association based in Montreal. So to the three of you, welcome to RTCA and to this month's webinar. As a starting point, I'm going to ask each of you to provide the audience with just a brief background on yourselves and your current role at your organization. So Ruby, why don't you start?
Hello, thank you, Terry, for the intro, and thank you for the invitation to join the webinar. So as you mentioned, I work at the International Air Transport Association based in Montreal. The scope of the work that I am in charge of or that I lead ranges from infrastructure related to air traffic management, whether it's communication, technology, spectrum, up to the future innovation with air traffic management and the integration of new technologies. Looking forward to the discussion today with the other panelists. Thank you.
Thanks, Ruby. Eric?
So Eric Corona, I'm the Director for ConOps and Airspace Development at WISC. I've been with the company for 3 years. Things that keep me up at night are the puzzle of infrastructure standards, the regulatory environment, and the ops testing required to get to an end state. And oh, by the way, this end state then provides further scalability. So we work very closely with industry, RTCA, of course, and with Boeing, right? As we're day in, day out work with Boeing on trying to advance these aspects. So thank you for having us.
Yep. Thanks, Eric. Amber?
Hi there. Thank you, Terry. I'm Amber Harrison. As Terry mentioned, I'm Aviation Regulatory Counsel at Zipline. I've been here for almost a year now. Prior to that, I have spent the last decade in-house advising aerospace companies on contractual, regulatory, compliance matters, and that's what I do here at Zipline. I help navigate the often very complex SUAS regulatory framework. And in my spare time, I'm a commercially rated helicopter pilot. I'm very happy to be here and chatting with you all on this topic.
Super. We're going to see just a few presentations from our three panelists. So Amber, since you already have the floor, why don't I just turn everything over to you and for a short presentation for us.
So let's jump right into it. We're Zipline. Our mission is to create the first logistics system that serves all humans equally. Very big goal, very important goal. And how are we going to achieve this big important goal? Two platforms that will be assisting in this mission. We're currently flying with Platform 1, which is our fixed wing parachute delivery concept. And coming soon, towards the end of this year, early next, we have our Platform 2, which is a fixed wing to hovercopter with a droid delivery system in it. And to go into a little bit of detail on each one of these aircrafts and how they work and how they help better our communities. Going into P1 first, as we call it, P1, we have a max takeoff weight of around 55 pounds, 2 hours of endurance, 56 knot max cruising speed. It's capable and built for 1 RPIC to multiple zips, as we call them. And it is built and designed to be easy to fly, easy to maintain in all kinds of conditions. So how does it work? We launch our zips via a launcher, as you can see on the screen here. Pretty interesting, easy technology. We deliver our package via a parachute drop. You can see that on the screen as well. that little red box to the ground. And then finally, we recover via an arresting line. So there's a tiny little hook on the back of our zip that, that hooks onto the arresting line upon recovery. And it does all of this completely autonomously. We have our PICs or controllers monitoring the aircraft and able to intervene if needed, but the technology does it for itself. And here you can see our global operations. We operate in Ghana, Nigeria, Rwanda, Cote d'Ivoire, Kenya, Japan, and then here in the US, in North Carolina, in Utah, and in Arkansas. And then to give you a little discussion on our P2, our Platform 2 aircraft, this is the new and exciting upcoming aircraft that is intended more for urban environments versus P1 that has more of a long range, rural environment type of concept. So you'll see, again, as I mentioned, we have a fixed wing aircraft that transforms into a hover aircraft, and then drops down the droid, which is where the payload is. Again, to give a little description on how P2 works, we load the droid. The droid then is pulled back into the zip, or what I call it, the mothership. The zip then navigates and flies to the drop location. It transforms into hover flight, lowers the droid, delivers the package, delivers the payload. The droid goes back into the mothership and it flies to a dock. The dock recharges the aircraft and is also where you can load the droid again for the next delivery. So as you can see, two very different aircraft, very different concepts, but together form the puzzle, if you will, to reaching some of these communities with these deliveries, be it blood, medical supplies, medical necessities, food, general consumer goods, etc. And we're doing this all at or below 400 feet AGL. All right, and with that, I will hand it over to Eric Corona from WISC.
Thank you, Amber. Exciting stuff happening over there at Zipline. Really cool. To set the stage, let me describe the aircraft that WISC is designing and building. And so we're looking at an aircraft for passenger seat aircraft. Its typical operating altitude will be 25 to 4,000 feet AGL, 50-foot wingspan, a range of 90 miles with reserves, and operating on anywhere from 110 to 120 knots. All of this to say that the mission that we are pursuing is that of urban air mobility over urban environments. And the key distinction and what sets WISC apart is that we are looking to certify the first commercially autonomous passenger air taxi. And what I want to just dissect a little bit what we mean by autonomous passenger air taxi and translate the marketing into more precise ConOps verbiage. This is a remotely supervised operation, one-to-many, where the aircraft is entirely self-flying, right? So that piece is autonomous. The human element is still providing oversight over communication and navigation. And if anything, we are repurposing the human to a new paradigm, which is rich with information. And yes, we're designing this aircraft to be able to operate in the NAS today. But the reality is that we're future-proofing the design to really take advantage of what we anticipate is coming down the pipeline in the form of information-based systems and AFR. So when we look at what's happening in the ecosystem, and in particular on the subject of ConOps, we have, WISC and Boeing published a document, but so have the FAA recently and just a couple of weeks ago, and then back in December of 2022, that all of these ConOps now speak about the direction towards this infocentric NAS, the adoption of automated flight rules that need to be defined, enabled by PSUs. And yes, there is a roadmap that allows us to go from existing current VFR, IFR, and a pathway and transition to AFR. And that's something that, that's what keeps me up at night. And that's what the ConOp that we proposed in September of last year aimed to do. Now, the main distinction, if I were to look at what we proposed and the FAA proposed as we look at this continuum, is we looked at all of these elements. We have the aircraft will have detect and avoid systems, landing and hazard avoidance systems. We have C2 links, we have vertiports, we have PSUs. We will start operations under IFR. And as a means of minimizing air traffic control interaction and starting to pave the path towards automated flight rules, we postulated the adoption of 4D flight plans end-to-end clearances that leverage trajectory-based operation fundamentals. Now, the idea was that we could start operations in the NAS by leveraging PSUs in shadow mode to capture and gather and validate the PSU capabilities. And again, here I'm starting to use the FAA's verbiage from their ConOps as a means of creating the gravel road that we then pave over to create these AFR routes. The FAA came out, and what we understood was that rather than leaning on enhancements in the current technology and their backend systems that would enable trajectory-based operations, that the approach was going to be looking at operational means for maintaining the separation and deconfliction, and that these operational means would then translate into this idea of we have a gravel road that we can then pave over and create these AFR routes in which air traffic control would maintain separation and traffic away from the term that the FAA uses, our corridors or AFR routes. In all, we saw the publication of the FAA ConOps as a really positive thing, because it effectively now starts to give us a clear picture of how we can go from the status quo in gray, where we start with crewed VFR, IFR operations. We can then transition to both crewed and uncrewed under IFR UAM routes, right? Extending concepts such as TK routes for helicopters, applying them for eVTOLs. Given how short our flights are, is introducing operational concepts such as implicit clearances, where ATC keeps other traffic away from us as an industry. And then ultimately this results in an enablement of AFR through PSUs, which, if you look at the ConOps that we proposed in September, PSUs would be running in shadow mode, collecting information and providing the foundation so that we can then transition from ATC services to PSU separation services, in addition to what other situational awareness capabilities they provide. So again, thank you for the invitation. And this is my cue to hand it off to Ruby Syed. Over to you, Ruby.
Thank you, Eric. Very interesting to hear from you and also the presentation about Zipline's work. Very exciting time for the industry, definitely. I will share with you the perspective that we have from IATA, and as Terry mentioned, it's the International Air Transport Association. So we're actually looking at this holistically, not just in terms of advanced air mobility, but also the different technologies that are coming into aviation, and what does that mean in terms of the aviation ecosystem. At IATA, we basically are involved in every phase of not just the flight, but even the passenger journey. So we have standards, best practices that cover a wide range of areas. And we are seeing technological advancements come into these different phases, not the different phases of flight, not only the new types of aircraft, but also how the passenger journey is going to look very different in the future. And that all, of course, is motivating member airlines who are part of IATA, because we represent airlines worldwide. This is all motivating airlines to think differently about the ecosystem, about the network, about airport hubs. How is that going to change, and what infrastructure will be required to support such change? And at the same time, the aviation industry is now interfacing with other modes of transportation that are looking into how the interconnectivity is going to look like, and what will be the standards required along that connectivity to enable it. There are also new players in the system, new players that have not been part of the aviation system before. This means that we have to work not only with new players, but also there's a learning curve on both sides, whether it's on the aviation industry side or these new players coming into the aviation ecosystem. And this kind of change is actually disrupting the whole system, and is causing us to think very differently about what we need to do in the future, not just within IATA, but how are we going to influence work, for example, at ICAO's level. So part of the conversation, not just today during the webinar, but beyond the webinar, is how can we look at this from a global perspective to ensure interoperability, harmonization, because manufacturers and operators will want to operate everywhere, will want to build the business model beyond just local operations. While we are looking at all these technological advancements, we have to remember that in many parts of the aviation industry, we have legacy infrastructure. And this legacy infrastructure is very safe, it's very secure, it has worked for years. But now we need to think about this legacy infrastructure that is associated with also legacy standards and legacy, let's say, regulatory framework. So what we are trying to do basically, or in very simple terms, is operate or drive a Ferrari on a road that was built for a vintage aircraft, for a vintage car. And now we are debating, or we are talking about this under the ICAO, let's say, framework, or even within IATA and also within RTCA, EUROCAE, etc. Do we rethink the road and just update and upgrade the road? Do we rethink the system and upgrade it, or do we think completely outside the box? And maybe there is no one answer. There is no either or. Most probably we will have to look at both, because the end state and what Eric was mentioning in terms of autonomous operations, in the future, the system will be highly automated, but there will be interim steps where we will have mixed mode operations. And this mixed mode operation is where we need to make sure that we allow the industry, the new aircraft technologies to grow to scale, while at the same time we maintain the safety and efficiency of current operations. And then how do we move together towards that end state? How do we make sure that we integrate the new aircraft technologies while we continue to grow existing networks? That is part of the question. The other part is that we are trying to answer with our members and we are working on is how do these new operations interface with existing networks, with aircraft that are being operated today, with airport infrastructure, and what new infrastructure will be required. And this is all part of an effort that started actually end of last year with a few airlines, some manufacturers, and let's say the new players in the space or the airspace domain to look at the future aviation ecosystem. What the future aviation ecosystem looks like, what is the vision for the future, and then what will be required to change in terms of standards, regulations, and infrastructure towards that. This will inform work that we do within IATA, but also it will inform some of the work that we do with ICAO. There are different platforms and groups that we are involved in, that RTCA is involved in, and together we will continue to work towards that end state and ensure the safe and efficient integration of new types of aircraft while maintaining at the same time, let's say, this coexistence. Because while segregated operations might work for the short term, in the long term, we need to look at the system as a whole. And this is the approach that we are taking from our side, and also working with our members because they are looking at this themselves. And happy to continue the conversation during the panel today with the other speakers. And with this, I'll hand it back to Terry. Thank you.
Great. Thanks, Ruby. And I think if everybody else can come on again, we'll kind of start with a little bit of a discussion. We've got some great questions already, so maybe I'll just get some of those out of the way to start. Amber, first one for you. Is ZIP operating beyond visual line of sight with 107 waivers, or is it something different?
Great question. We are not operating beyond visual line of sight in commercial operations under Part 107. We do have a Part 135 certificate, and that is what enables flight beyond visual line of sight currently with visual observers in commercial operations.
Right. And do you see your concept of operations moving beyond, say, just providing supplies and packages to even to other sorts of cargo people in the future, or are you strictly focusing in on one segment of this?
I don't foresee a world where we would be transporting people, but I could envision a world as our own technology and infrastructure develops, increasing the size of the payload that we're able to carry. Currently we have around a 3 to 5 pound payload. And like I said, I think as technology improves, as the infrastructure improves, I could see us increasing that, but definitely not up to the size of a human.
And Eric, at WISC, what sort of detect and avoid systems are you planning on using for autonomous ops?
Great question. So the aircraft will have detect and avoid systems on board. I won't go into the characteristics of it because that is the IP part of the company. But the one thing that I will say is when we look at the ConOps and we look at the infrastructure, the detect and avoid piece is really the last barrier of defense in conflict management, right? And so one of the things that we're doing is how do we provide, starting from route design that is, deconflicted as much as possible from existing air traffic, we're not going to put this on the pathway of LAX, pick your runway, right? That's the black and white example. But deconflicted routes, number one. Two, how can we use information on existing flight plans such that we, again, then minimize interaction or possibility of interaction with those aircraft? Three is if we have a situational awareness, right, similar to how air traffic controllers have that awareness today, we can anticipate issues. And then and only then, if we are not able to identify an aircraft, then the detect and avoid comes in. Now, one of the things that I can say about the detect and avoid system from Wisk is it doesn't tire, it's always looking, and you don't have to train it to scan the sky in segments, right? And so one of the things that we're postulating is these detect and avoid systems will actually be more reliable and effective at doing that last, level of defense.
And probably something for you as well, Eric, is you brought up the automated flight rules or digital flight rules, or there's a lot of different terms for it out there. And as you move from VFR to IFR to this kind of new set of this paradigm of flight rules, how do you address weather issues with that?
So
how are you going to get that weather information into make sure you're executing in a safe manner?
So, and when I provide my response, I'm going to limit my response to urban air mobility, right? So these routes are on average, 30 miles, potentially even 50 miles, but that's the span of, because of that's the urban sprawl. And so we will know what weather is, right? We will be continuously monitoring. The uncertainty that can come from weather will be fairly limited, and that we will have the information both visually, operationally, but also digitally. Now, how we account for this weather will be similar to how IFR aircraft deal with it today, right? There's a weather forecast, blah, 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 blah. You plan your flight and you go. If I were to summarize the main characteristic of AFR, it is the ability to transmit intent and acknowledge intent for a whole set of participants in that airspace. If I am IFR, that intent is communicated via voice, potentially CPDLC, right? And so even IFR is transitioning in that direction. Weather is just another element where an operator will take that into consideration and convey intent such that other participants can react as well. So on the topic of weather, it's not too far, not too distant from how IFR aircraft treat it today.
Okay. I'm really, what you were kind of discussing really was going beyond just looking at a regional approach to concept operations into a more broader aviation ecosystem, if you will, and how it's all connected. And we certainly have seen some of the larger US carriers and maybe some other carriers around the world that are teaming up with some of these new AAM sort of companies. And how do you see that all kind of coming together with some of your members?
Thank you for the question, Terry. And yes, so what we are seeing from our members, it's a bit of a different approach. So some of our member airlines and maybe you and the participants in the webinar have seen the press releases. They are investing in these new types of aircraft. They are looking at AAM operations as feeders to their major hub airports. And from a business perspective, airlines are looking at the passenger journey door to door, not airport to airport. And that changes the dynamic of operations. That requires the operations to have standards that actually cover the door-to-door operations, which we haven't seen in the aviation system before. So in terms of passenger identity, digital identity, and digital ID, we are looking at it. We are also looking at it from other standards that we have for carriage of passengers and cargo, because also the carriage of cargo, for example, by Zipline, if that's going to be cross-border and at a scale, then that might also require international dangerous goods standards, cargo handling, electronic airwable. So the whole aviation ecosystem needs to transform around that. It's the airspace integration is one very important piece, but it's one piece of the full equation. And that's why we're looking at this at the system level in order to make sure that operations will be ready. And we have to remember, or we have to take one thing into consideration. Some operations are planned to start by next year and even 2025. There might not be, they might not be at scale at the beginning, but the growth that is expected, the rate of growth is higher than we have seen in aviation. So that's, and given the cycle of developing regulations and standards that we are used to in aviation, this is where we are trying to make sure that we bridge the gap between the innovation cycle, the technology cycle, and the regulatory standard cycle.
So one of the things that always comes up in discussions is even some basic concepts, and whether we're talking AAM, UAS, UAM, UTM, all these different sort of acronyms or abbreviations. There's probably difference of views in terms of what we should be focusing on today versus longer term, but I'll open this up to anybody who wants to jump in terms of what are some of those differences, what are your views on some of those differences, and where should the focus be today?
So I can maybe take the first bullet. So, I think that if we look at this 5 years from now, we will see that these terms will start to converge into one single paradigm, right? And so when we talk about UTM, right, that was a term that started with 400 feet and below. Advanced air mobility was was an academic term that was looking at this new evolution that's coming up. Then we have urban air mobility, which is just the flavor of advanced air mobility applied over an urban sprawl. Now, I can assure you that there is a company out there that is going to come up with a new use case that is not going to fit in this puzzle, and they're going to come up with their own term. At the end of the day, I think what's important is, as an industry, we are transitioning and leveraging an information-based underpinning to enable a new form of operation. This is digital transformation coming to aviation, right? And so I don't get held up on, what's the difference between UTMs and PSUs. It's like, there's going to be a continuum 5 years from now that arguing about it is really detracting energy from the industry, as opposed to we should be focused on how do we blend it. Because, I want to know where the zip lines are at, and the zip lines want to know where I'm at, right? It doesn't matter what you call it. So.
Great.
Very eloquently put, Eric, and I completely agree with you. I'll say it's much less about the alphabet in the soup as much as it is on the soup itself, and agree that I think at some point all of these terms are going to converge. What really matters is getting a system in place that works for everyone. We have that in traditional aviation to some extent, and so now we have to come up with the piece that folds the rest of us into that recipe, if you will. Suddenly, I'm on a food journey. It sounds like here, but I completely agree, Eric, and yeah, it's not so much of a focus on one as it is the whole picture.
I agree with that. And actually from our side, we see the UTM construct helping us transform air traffic management, because this is also, I mean, from our side, it's not just about the AAM operations, it's new aircraft technologies. It's there's higher and higher automation in the flight deck with traditional aircraft. There we have a lot of data in the industry. How can we make use of it to have better intelligence, better precision, more predictability, etc.? So Terry, I think we need to look at this as maybe also an opportunity of how we can leverage the UTM construct to transform how traffic is managed in an airspace. And this is not a let's say a short haul discussion. I think it's more a long haul process, but still the way aviation really moves and the pace that we move with standards, I think it's timely to start having these conversations today amongst the stakeholders.
Exactly. Great. I'd like to kind of just touch a little bit on the regulatory environment that you're all working under. So there's some questions that kind of touch on that as well. So, we tend to think kind of FAA centric a little bit, but are you all partnering with some of the other regulators around the world, especially like EASA, and anybody else when it comes to the regulatory certification and operational approvals?
Yeah, I'll take that one. As I mentioned earlier, we do operate in quite a few countries around the world. And so we are coordinating with each of those individual aviation authorities. So in Japan, in Cote d'Ivoire, in Ghana, in Nigeria, they all have different agencies that we work with. And then obviously FAA here in the US. So sometimes things are the same, but sometimes they are very different.
Yeah, and we've certainly seen, the FAA and EASA have taken a little bit different approach to this, and which is difficult, I imagine, from an industry perspective. That when you want to try to get your vehicles and operations certified in two different regulatory environments, that's not easy. So, but yeah. Eric, any thoughts on that?
As a U.S. company, our orbit is, naturally the FAA in the United States. It's no secret we have operations in New Zealand that are taking advantage of the forward-leaning ecosystem there to enable, remotely supervised operations to happen and autonomy. Recent announcement in Japan, and obviously we've had conversations with EASA. As it pertains to the ecosystem, however, we obviously monitor all of the activities that are happening in APAC, in the US, and Europe. And interestingly enough, Europe may call it a USSP, we may call it a PSU, but the information and the principles are very similar. I would even argue that within the standards bodies, and you're probably better positioned to confirm this, you start to see cross-pollination. And so I think that's important, right? So you have a type cert discussion, but then you have an ecosystem discussion. And getting the ecosystem to be compatible is extremely important.
And I think we've been, it's been very not easy, but we tend to focus so much on the vehicle capability and getting those vehicles certified. The real challenge, I think, is going to be that integration piece and how they actually get that operational approval going forward too. So,
and may I add a question, a comment there, Terry? Is I would argue that when folks challenge me on saying, "Hey, the technology is not there," I would argue, yes, it is. We have GPS, we have wide augmentation systems in place. We have, pick your LEO orbit. There's a satellite for communications. these satellites are already being used for communication, et cetera, et cetera, et cetera, right? So now it's really putting the pieces together. It's not about technology development, a little bit, but it's primarily about the integration of the technology and exercising that technology through operational means. And I would even argue that a lot of this technology already aligns with existing standards, which is a blessing. It's a blessing, right? And so
I'm sorry, go ahead.
and so many folks feel or have this perception that our type of operations are far removed and the scalability is a far away thing. I would argue that today, if we were to deploy our technology, people would start operating our systems today. It's not a technology thing, it's a integration and commitment as a nation thing.
Yeah, I mentioned the AAM workshops we've been having here in our offices, and I kind of was going into it at the start of the year thinking, okay, RTCA, we're a standards development organization. What should we be working on to, help, engage the community, help get some of these new technologies implemented. And one of the things that came through was, in many cases, it's not new standards that are going to be required. It may need some tweaking of existing standards to accommodate the AAM community, but it's not like it has to be a whole big full-blown standards development activity. In some cases it might, but in general, it may be just a matter of taking some of those existing standards and getting them tweaked and seeing how they can best apply. So it's one thing I've learned this year on the topic. So, and that kind of brings up, and for Rudy, you kind of work on this too, but are there differences of expectations between those of industry and those of the regulator that you see from an international basis?
So I think there are different expectations. I think as Eric was mentioning, it's maybe a shift in mindset, because the future means more flexibility and less structure, maybe. And we are used to structure, and the structure has been working for a long time. It's safe, it's working, the system has worked. But now with more data and more digital applications, there's less structure, there's more agility, there's also maybe a shift in the roles and responsibility. And that is where people maybe are less comfortable, as Eric was mentioning. It's not about the technology, it's being comfortable in that shift. A shift from human supervision of every tactical function to human managing the system. And then it's a system also doing the tactical, let's say, mitigation. We are an industry built around mitigation by a human to any risk. So that is a shift in mindset. And I think that maybe industry, and as Eric mentioned, for example, their experience with WISC, they are comfortable with the technology, they are confident, they are ready today. The regulators might need a bit more time to be comfortable, and it's trusting that system to do what it's supposed to do. And that requires, in my view, or in our perspective, closer collaboration with industry. I mean, we attended the workshop, both of us, Terry. I think maybe we didn't have enough representation from this new industry, the new players. So we need to bring in more of these new players, learn from the trials and use data to create the standards. And maybe it's also a shift in global standards in the sense that it's a bottom-up approach rather than waiting for a standard to be developed in 6 years and then it may not be fit for purpose.
Exactly. Yeah, that's right. Amber, any thoughts you have on the expectations of regulators versus the industry?
Oh, where do I begin? No, I agree. I absolutely agree with what Eric and Ruby both have mentioned. The technology is there, and it's just a matter of the regulation, the infrastructure running to join, right? And what I think would be really detrimental to the industry is taking too long for that piece to catch up, because at some point, if we continue down this path of roadblock after roadblock after roadblock, we're gonna lose some of these really important players, these new players in this field. We're gonna lose this important technology, and that's just the fact of it. We have to do more to make sure that we're keeping up with the demands, that we're keeping up with technology, and that we're keeping up with what our society needs.
So, Ruby, you mentioned the some of the work up at ICAO. We're both on this new AAM study group up there that was just convened last month. What do you see ICAO's role in this, in getting some of these different operational concepts implemented, or any other part of it that you think ICAO should be playing?
Yeah, thank you for that, Terry. And the primary, let's say, driver for ICAO to be more involved is that we are going to see cross-border operations. So I think Eric mentioned it before, just looking at this new entrance only below 400 feet, very local, that is not the business model. And both Eric and Amber can confirm, but that is not the business model for most of these companies. So we need to look at this from a system integration, and that is where the underlying principles and let's say assumptions need to be addressed. And this is where, for example, a discussion about flight rules. Is it a new set of flight rules? Is it a rationalization of existing flight rules? We need to have that conversation, because it's not just about the AAM, it's also about technology on board other aircraft. When we talk about aircraft certification, it's not just about AAM, it's hydrogen powered aircraft, it's electric aircraft, it's SAF. You know, there needs to be a shift in some of these work areas, and you know, ICAO has so many people and so many hours in the day, so I think a prioritization is also required, which is why the study group was put together to provide that kind of recommendation of where ICAO needs to focus. We do see their role being very critical for the global interoperability, which is critical for both manufacturers and operators.
There was a couple questions that kind of got into the need for some sort of a roadmap. I know we've seen, I think Eric, you mentioned the FAA's new revised roadmap that they came out with a couple of weeks ago, and I know EASA has some roadmaps. Is there a need for more meat behind those roadmaps, or some way to get all these different roadmaps connected together in some way, so that we're all kind of driving towards the same sort of timelines and solutions and needs for the industry, needs for the regulator? It seems like that's one thing that's missing out there.
Yeah, so absolutely. And I think this is where industry can come in, right? So industry is looking at, how do we certify these aircraft? How do we operate these aircraft? We meet within standards bodies. And therefore, that's the reason why WISC and Boeing made the ConOps public, right? So that this could be a public conversation. So when we look at, digital flight rules, or AFR, in the past it was, do we need them? Then it was, what are the elements necessary to enable them from an information standpoint? Look at the conversation we're having now. It's amazing, is let's define them, right? Yep. And so we're past those first two hurdles. And now we're having the conversation that is essential. And from an industry perspective on a roadmap, I would argue, if we compare IFR today that enables me to go direct, and I compare that with IFR 30 years ago that did not allow me to go direct, right? There's precedent where I don't have to get it perfect, right? The end state from day one. But having the ability to lay out how operations begin in a safe manner, I think is where industry can help. Partnership with regulators is essential. And one of the things that I would add to what Ruby mentioned is the joint operational testing, so that we can demonstrate, industry has a responsibility to demonstrate that these technologies and integration work to the regulator. We would look for the regulators and the ANSPs of the world to open the doors and provide a means for our industry to test and validate and convince, gain their trust that we're designing to the maximum levels of safety in the case of WISC, which is passenger carrying.
Right. And when you talk about the need for the ability for scalability of all these different operations, we've got to come up with something besides VFR and IFR. We've got to have some other means of being able to accommodate that a very large number of operations that go beyond traditional flight. And that's one reason, I reached out and we got the focus group together, and we're developing a white paper, if you will, on digital flight, because I think it's really important to bring industry together and start getting these things down on paper, and so that we, something like that's not a new concept. It's been around for a long time. And Eric, I think you were in the audience last week when at the AUVSI Expo, and I said we got to start moving forward on some of these things and getting moving, because we can't be talking about these same things 10 years from now. We've got to keep moving forward. So,
and if I may add one thing is, I'm going to remove my engineering cap, right, and put on a policy cap and say the airspace is a common good, right? What industry is looking to is unlock value that is in that airspace, providing services. WISC is convinced, and industry is convinced, that we can deliver Uber-like prices to urban air mobility. That value proposition needs to happen as a partnership. Industry is doing part of it. And one of the things that I shared with you in Denver was, it's not a matter of if, it's a matter of when and who. And I would argue that the when, given that the technology is now, there's no excuse to delay it.
Ruby or Amber, any closing comments?
From my side, I just to connect everyone. For technological advancements, we see it as a way to enhance and improve that. So working together with the industry, with RTCA and others, I'm sure that we can realize this future, and looking forward to the next step. Thank you.
Amber?
I'll just say there's a saying, don't confuse movement with action. And I love the idea of developing roadmaps. I love working groups coming together to solve big problems. But I would challenge us all to take that a step further and really start providing regulatory frameworks that work for everyone in industry. That's the only way that we're going to be able to scale our business. And I think we could probably say the same for you, Eric. We have to have more. And so talking about it, thinking about it, these are all great things, but without action on the regulatory front, they just remain ideas.
Time to roll up our sleeves and put the pedal to the metal, if you will. So
exactly.
Amber, Eric, Ruby, I know we could talk for another hour, I'm sure, but I do want to thank you all for being with us today, for taking the time out of your schedules to share some of your insights. All three of your organizations have been great supporters of our TCA, but more importantly, we stand by to support you and helping you be successful. So thank you so much for doing this. and appreciate it. So thanks.
Thank you.
Everybody.
Thank you.
I've been speaking today with Ms. Amber Harrison, the Regulatory Counsel for Zipline, Mr. Eric Corona, Director of ConOps and Airspace Ecosystem for WISC, and Ruby Sayed, Head of Air Traffic Management for the International Air Transport Association. Great discussion. I know we all appreciate their valuable participation in the discussion this afternoon. For the audience, I thank you for joining us today. I hope you found today's panel educational, inspiring, and evolving. And again, these webinars are being recorded, so if you want to review anything presented today or any of our past webinars, you can do so by going to the RTCA YouTube channel. Again, the ability for us to bring you these webinars wouldn't be possible without support of our members. So this year, I'm very pleased again to thank our gold sponsors for this year, Collins Aerospace and the National Air Traffic Controllers Association. We all appreciate their support of RTCA and for this webinar series, so thank you. Again, I want to remind you about our upcoming RTCA training courses that we're going to be having in June, next month, June 5th through the 8th. Our course on DO-178C, Software Considerations for Airborne Systems Equipment and Certification. June 6th through the 8th, our new Human Factors course in the design and certification process, and then followed by our Airworthiness Security certification course on June 26th through the 29th. Again, you can sign up for any of these courses at www.rtca.org. As I mentioned earlier, in addition to these webinars, I'll note again that we've been hosting a series of AAM workshops in our offices that have included participants from manufacturers, equipment providers, operators, industry associations, and the FAA. If you're interested in seeing a summary of those discussions, or you can certainly find those, they're posted in the news section of our website. And if you're interested in attending any future ones, just let us know and we'll get you on that invite list. Our next webinar is going to be held in July. We're going to take the month of June off because it's a very busy month, but we'll have our next one in July. We're going to be talking security. Again, to the audience, thank you for taking the time with being with us. Have a very safe upcoming Memorial Day weekend. And again, we thank you for making RTCA a part of your day. So long.